Good morning. Myself Dr. Gangadar Hugar, Senior Lecturer, Department of Applied Sciences, Chandigarh College of Engineering and Technology, Diploma Wing, Sector 26, UT Chandigarh. And I take this opportunity to wish you belated Happy Teachers Day to all. And today we are going to discuss about the chemical bond characteristics and concept of hybridization. First of all, the chemical bonds and their characteristics and concept of hybridization in chemical bonding for first semester Punjab State Polytechnic students. So why we should study this chemical bonding? First we should understand this. Therefore, let us summarize the objectives of the study of chemical bonding. Knowledge of chemical bonding for engineering students is essential in order to understand characteristics of materials used in their engineering professions. Second, it will help us to ascertain suitability and sustainability, this is very important, of the material to be used in producing finished products. अगर हमने कोई मैन्युफैक्चरिंग करना है उसमें मटेरियल तो यूज़ होगा, वो मटेरियल यूज़ होने का क्या सूटेबिलिटी है उसका और सस्टेनेबिलिटी कैसे है, ये जानकारी हमारे को पहले होना जरूरी है. सो ascertaining the behavior of used material in finished product while product is in use. एक बार हमने यूज़ किया और उसके बाद उसको कैसे क्या वो सस्टेनेबल है कि नहीं, इसका भी हमारे जानकारी होना जरूरी है. सो देयरफॉर वी आर गोइंग टू डिस्कस ऑल दीज थिंग्स इन द times to come now. So what are chemical bonds and their characteristics? You must have studied in earlier classes that ionic bond, types of bonds, covalent bonds, which are both discussed here, and there are the other two bonds like say bonding in metals and hydrogen bonding. Though these are the different types, all the types of bondings, but in this lecture we focus on the characteristics of ionic bonds and covalent bonds. So apart from that, we will also see what will be the why we have to discuss the hybridization in chemical bonding. So with reference to this, we have to define that, and we will see the types of chemical bondings, hybridization and bond characteristics. So thereafter we will study the comparison of ionic and covalent or molecular bonding. So this is the discussion what we undertake now to the best possible time. So as you know, what are the types of, first I would like to take up the ionic bonding. How you define a bond? A chemical bond is a force that holds the constituent particles of the molecules together. Suppose if you have, let us take sugar molecule or sodium chloride molecule, how these sodium and chloride are held it together in the crystal lattice, or how these 12 carbon and 22 hydrogen and 12 oxygen are held in one molecule of sugar. So this force that holds the constituent particles of a molecule together such that it should acquire stability. The more important is stability, and apart from that it should occupy a definite geometry. So that definite geometry gives a more stability to the molecule, and therefore it is necessary to understand the bonding. And in chemical bonds, in fact chemical compounds can be broadly classified into two types based on the type of bonds they possess. You know that, namely ionic compounds, that is common salt example, and covalent compounds, that is sugar, etc. So we use these things in our day to day life quite oftenly. So you have studied ionic bond, or it is also called as electrovalent bond. An ionic bond is formed by complete transfer of electron or electrons from one more electropositive atom, generally metal, to more electronegative atom, generally non-metal, in an ionic compound. Every ionic compound always contain two types of ions, namely cation. Cations are nothing but positively charged ions and anions are nothing but negatively charged ions. So, the cations are formed. How are the cations formed? The cations are formed by the loss of electrons, which is also called as oxidation. So, by the more electropositive, generally as I told you earlier, they are metals. So, anions are formed by the gain of electrons or by more electronegative atom. More electronegative atom is generally non-metal atom involved in ionic bond formation. So, let us consider. So, what you have studied in ionic bonding? So, we have to recapitulate that ionic bond formation in an ionic compound, which will help greatly to understand the characteristics of ionic compounds. So, the characteristics of ion bonds are mainly depending upon the how they have formed. Therefore, let us consider the formation of sodium chloride, which is a common salt, contains sodium cation and chloride anion. Here I am going to write only important steps of a Barnable cycle, and where we have already studied in the bond formation. So, sodium I am not I am skipping some of the steps here. Take the sodium atom in a gaseous state, supply it ionization energy, so that sodium cation in a gaseous state is formed with a elimination of an electron from the outermost 3s orbital. So, as to become the sodium cation more stable, and this process of loss is called by a loss of an electron by an atom is oxidation. So, therefore, sodium atom get oxidized to sodium ion, and on the other hand sodium when lose electron, and chlorine gas when it takes the electron, it has to liberate more energy, which is called as electron gain enthalpy or electron gain energy, to form chloride ions, which will acquire an extra electron, and it becomes the more stable chloride ion, which is called a reduced, because chlorine atom changes to chloride. So, ultimately when you just make the sodium chloride, sodium to react with chlorine gas, sodium gas to react with chlorine gas, what happens? Sodium here ionization potential, electron gain enthalpy, and when you see the sodium ions here, sodium ion combining with chloride ion to form sodium chloride, and it also produce lot of lattice energy, that is this lattice energy and electron gain enthalpy or electron gain energy are quite high, which is liberated, whereas ionization enthalpy is being absorbed by the sodium, and therefore, what happens? The amount of energy liberated in this result formation of sodium chloride solid will be much higher than the ionization energy, hence formation of sodium chloride ionic crystal takes place. So, therefore, what are the characteristics of an ionic compound then? So, there are many important characteristics of ionic compounds having ionic bonds. First of all, an ionic compound is a collection of an equal number of positive and negative ions arranged in the 3-dimensional lattice. So, if you take this this is a 3-dimensional lattice. I have taken only one molecule because it is a formation reaction, and after the lattice formation there will be huge ions which are systematically arranged in the 3-dimensional fashion, and that will give you a lattice energy, and therefore, ionic compound can be dissociated into their constituent ions with little effort. For example, if you put the sodium chloride in water, what will happen? The water can also break the attraction force between the anion and cation of sodium chloride. So, therefore, when they split and they are going to dissolve, this is why ionic compounds are water soluble. All ionic compounds are generally water soluble. So, that is a characteristic property. So, but that all dissolves are not ionic, as you are aware, sugar is not a ionic compound, but still it dissolves. The reason is different, because there is a different bonding is involved. Therefore, ionic compounds are water soluble because of the dissociation, that why we can definitely say. Moreover, ionic compound can conduct electricity either in molten or aqueous state. So, only in molten or aqueous state these ionic compound conduct, because there is a flexibility for the ion to move in the applied electric field, and therefore, they can carry current to from one, therefore, they can and hence this application can be used in the electroplating and in fact manufacture of certain metals, for example, electrolysis of bauxite, so with adding flux like cryolite etc. So, that is, and if you reduce that element, these ion can also reduce to their respective element, and covalent molecules of the constituent atoms you can get it back by electrolysis as well. So, most ionic compounds are made up of metals, most electronegative non-metals. So, this is so that is why sodium chloride, if you take, this belongs to the first group, and chloride ion belongs to 17 group, which are more electronegative, these are more electropositive. Therefore, the existence of any bond between the sodium chloride is ionic, since it is a more, it is the bond formed by the transfer of electron from sodium to this is sodium electron has been transferred to chlorine. So, that is why they are very generally formed because of between the first group elements and first or second or metals to with non metals like sodium like 17 group elements. Ionic compounds are generally water soluble. Okay, this is also very important characteristics. Okay, and which are, and they also possess a high melting point. Why? Because these ions, suppose if you take sodium ion here, its field, electric field is uniformly distributed in a circular, in a spherical manner. So, its chloride ions, therefore, it is non-directional bond, and hence it is very strong. It is very strong. Therefore, the compounds will have maximum melting point and boiling point. So, therefore, ionic compounds have the following characteristic property because of their bond formation, and we can say that it is the ionic bond which makes them to have such properties. So, therefore, ionic characters are due to these ions present in the reactor. And one more important thing is that the sodium or ionic compounds, they react faster than covalent or covalent molecules or the other compounds like sugar etc., because which are covalent in nature. Okay. Now, we will see some of the properties of few ionic compound. Look at this sodium bromide, formula NaBr, which exists in solid state at a ordinary temperature and pressure, which has 757.7 degree Celsius melting point. Solubility, it is a water soluble. Even potassium sulphide K2S, which is also solid at room temperature and with a high melting point. Look at that 910, and so there is a zinc sulphate, which is also solid, it is ionic compound and having high melting point, having excellent solubility in water. So, the physical property and even to some extent chemical properties are also depending upon the bond present in them. So, ionic reactions are more faster than covalent reactions. This is the due to the presence of ionic bond in certain in the ionic compounds, or which are also called as electrovalent compounds. Okay. Now, we shall see the covalent or sigma bond formation by S and S. You should write these are small s, because this is s orbital of one atom and another atom, they overlap to form covalent bond. So, what is covalent bond? A covalent bond is formed by overlapping of S and S atomic orbitals having oppositely spinning electrons, opposite. So, it may be S and S, it may be P and P. If you go for the, we are going to take up that one in the next slides. So, first we shall see how the covalent bond formed when the two atoms have one electron in their S orbitals. So, consider the formation of dihydrogen molecule. So, dihydrogen molecule means H2 molecule. In the molecule of dihydrogen, two atoms with opposite spin electrons in the one s orbitals overlap to form a single covalent bond. So, here the bond formed is called sigma bond, and since the overlapping of s orbital is always maximum, and therefore, sigma bond formation release high energy, which ensures stronger covalent bond in dihydrogen. So, suppose if you look at this one, these are two hydrogen atoms, as they reduces their inter atomic distance, their s orbital get overlapped, and I have tried to show these pairing electrons here, and this is the internuclear distance with a minimum potential energy. See, once we have this, this will see when they approach each other, their atomic orbitals get overlapped, and this is due, and thereby which they can able to share their electrons. So, therefore, one s electron, one of hydrogen, the other hydrogen, then potential energy decreases substantially, and therefore, they will be at this combination of two hydrogen as a entire unit can be act as a molecule, and therefore, the covalent bond is formed by the overlapping of the s orbital here. So, s and s both, therefore, the bond formed is sigma bond, because this is a, and they cannot come even not less than this, they cannot come even closer than this, because even if you they do so, then repulsion force increases and they will depart. So, therefore, bond will become unstable. So, this is the minimum distance which will experience maximum attraction force and give stability, and therefore, this s and s overlapping of the orbitals of hydrogen atoms will give the stability, and hence H2 exists in a more stable and it lot of energies we must have liberated when the SS overlapping sigma bond formation has taken place. So, therefore, this is one of the important covalent bond, which is a sigma bond. Sigma bond can also take place when p and p orbitals overlap. A covalent bond is formed by overlapping of p and p atomic orbitals having oppositely spinning electrons. So, for just I would like to take the example of chlorine molecule. In the molecule of chlorine, two atoms with opposite spin electrons in the 3p z orbital overlap coaxially. Coaxially means you know that 3p orbitals have three different orientations, which are 3px, 3py and 3pz. In chlorine, 3px is having 2 electrons, which we am going to show in the next slide. So, I would like to take 3pz because we want to take the z as a coaxial orbital. I have one atom with another, which will coaxially overlap to form single covalent bond, and therefore, maximum overlapping is possible here. Therefore, a sigma bond between chlorine and chlorine atom is possible when 3p z orbitals overlap with the maximum overlapping. So, such a sigma bond formation releases high energy, which ensures the strong covalent bond in chlorine. So, let us this ideology recapitulate by the graphic, a qualitative graphic representation. We have tried here a covalent bond formed by overlapping of atomic orbital with opposite spin. Let us say, see here, this is the chlorine atom, 3, I am writing only outermost electronic configuration, I have left it inner core electron configuration, 3s2, 3px2, 3py2, 3pz1. See, this is a having one electron of one chlorine atom, this is another chlorine atom with another electron in the 3pz. Okay. So, when this is the 3pz, I am just representing, and this is also 3pz, when they come coaxially and approach coaxially means in a single line like this. So, these are this is the nucleus, let us say this is the internuclear distance right now, and when they start moving, say there when they approach, then at the end they will stand at this particular distance, and this internuclear distance with minimum potential energy and maximum stability. So, this is leading to the overlapping of p and p orbitals. So, thereby they share their oppositely charged oppositely spinning electrons in their p orbital. Hence, the covalent bond formation is taking place. Okay. So, let us see this one once again. See, this is the internuclear distance reduced and potential energy gradually decreases. There they overlap and share their electrons, and at this mean distance between the internuclei, then which gives more stability to the chlorine molecule, and hence it is covalently bonded. So, this is another example we can see. This is a non-polar. Why? Because both these chlorine atoms which are sharing their electrons in the p orbital of Z orientation, then they have same tendency. Therefore, these are equal distribution between the two nuclei, hence there is no polarity. And so, same thing is case when you see the two p orbitals of the fluorine, when they overlap, see coaxial overlapping, and electron distribution is uniform between the two nuclei, and thus formed bond is due to the sigma bond, and it is sigma bond formation, and therefore, so when p orbital of F overlap, there is a molecular orbital which will give you a stability. So, this is also a fluorine single covalent bond which has no poles, because tendency of attracting the electrons of these two are equal, and hence this is uniformly distributed. Therefore, there is no polarity like positive or negative. We have seen that one sodium chloride molecule wherein the sodium is completely transferring its electron to the chlorine atom, but here they are not transferring, they are merely sharing. Therefore, these are covalent compounds, covalent molecules, and in fluorine molecule or any non-polar covalent bond, the sigma bond is symmetrical, means that there is a density distribution between the two nuclei is uniform. Okay. So, that is next. Let us see there when in some molecules when the sigma bond is formed, sometimes a pi bond can also form. So, let us take the example of oxygen molecule to understand the covalent bonding along with sigma and pi bond, which can be pi bond in previous cases. Here in this case, look at this, it is the p and p orbital coaxial overlapping giving rise to covalent bond. Even p and p orbital can also give pi bond also. That is why we have taken the example of what is called as oxygen here. Consider, though the best it can be explained on the basis of the molecular orbital, but we are restricting to not go to the molecular orbital theory. However, we want to explain you on the basis of the overlapping only, p overlapping about pi bonds along with the sigma bond formation. So, this oxygen molecule has been taken as an example. So, after the sigma bond formation by overlapping of 2p z orbital of the oxygen, then the unpaired electrons present in px and py, they can also py one of the either of the px or py will overlap laterally to form one weak pi bond. So, the extent of overlapping here in this case is minimum, and hence the bond formed is weaker. Therefore, coaxial overlapping of p orbital can lead to the formation of first sigma bond. Remember, first sigma bond will be formed. Then if there is a possibility that the electrons are there in the p orbital which are perpendicular to the coaxial formed covalent bond, they can overlap laterally and then they can form the pi bond. Therefore, you should remember the pi bond can only form once there exists the sigma bond between the combining atoms. Okay. So, let us see the pictorial diagrams of this. See, I have written here, consider the formation of pi bond in a molecule. Let us take example of oxygen in its ground state 2s2. Again I am reiterating that we am writing only the last electronic configuration here, 2s2, 2px2, 2py 1 and 2pz1. See, there are 4 to 4 plus 2 6 electrons in the outermost second shell of the oxygen. This is one atom, this is another atom, they are going to overlap coaxially. This is I am showing only two orbitals, that is p y and p z. See, out of that p z is coaxial, that is not a shaded orbital. These orbitals which are coaxially, only one can come coaxially, na? That is why I am showing p z, and when we just see that they will come coaxially and then share these their unpaired electrons in this. This is opposite, one is having parallel spin, another one is having anti parallel spin. Again this distance, internuclear distance, will be a bond length, and this bond is called sigma bond. Now look at this, as this bond gets decreased, because sigma bond is a very strong bond and brings these two nuclei closer, therefore these p orbitals now overlap laterally. So then px or py orbital which are perpendicular to pz overlap laterally to form a weak pi bond, and since the extent of overlapping is minimum here, and therefore this is not a two bonds here, it is a upper lobe lower lobe, this is just like a coil, and in between that there is a sigma bond. So therefore you can see in the oxygen molecule there will be oxygen oxygen double bond. So therefore this is the one type where the covalent bond can also form by the coaxial overlapping of atomic orbitals with having opposite spin to form sigma bond, and lateral overlapping of these orbital can lead to a weaker bond called pi bonds. So oxygen is having one sigma bond and one pi bond. Okay. And this formation, when these two atoms come at this intermolecular distance bond length, then their potential energy is very low and they are very stable, very stable. Okay. So this is now let us go to another pi bond. Here we have seeing the pi double two pi bonds, one sigma bond. First, of course, if you take the nitrogen molecule, when two atoms of nitrogen having oppositely spin electrons in their two pz orbitals overlap coaxially, they form a single sigma covalent bond. After this, the bond both px and py which are perpendicular to the pz orbitals combine laterally or overlap laterally to form a weak pi bond. The extent of overlapping is minimum, thus pi bond are weak. Therefore, coaxial overlapping of p orbital can lead to the formation of a sigma bond, then the formation of pi bonds follows if the remaining p orbitals undergo lateral overlapping. So, in case of nitrogen, we will find here, look at this. So, see, nitrogen, I am writing outermost electron to a electronic configuration 2s2, 2px1, 2py1, 2pz1, one nitrogen. The another nitrogen, when they combine, first of all coaxially they will overlap pz having opposite spin to form sigma bond, and these two they will overlap laterally, and when they come closer, then their energy decreases and they share their oppositely spin electron, and this will be the internucleus, and they overlap laterally px, the remaining either px, and now it is px and the other one is py also overlap. So, there are not 5 here, this is one sigma bond and 2 pi bonds. Therefore, in a molecule of nitrogen there is one sigma bond and 2 pi bonds. So, this is what the nitrogen molecule, and it is very stable. You know, in the atmosphere we have nitrogen and it can only undergo reactions at elevated temperature under drastic condition, because the breaking of these three covalent bonds between nitrogen becomes very difficult, and therefore, we can make it only happen at a elevated temperature because of the existence of three bonds in between two nitrogen atoms in a molecule of dinitrogen. So, this is helps you to understand the formation of a pi bond between the atoms once the sigma bond is formed. So, therefore, So, we quite oftenly say what are the difference between sigma and pi bonds. See the pi bond, this you can expect a question from this, compare what are the differences between the sigma bond and pi bond, or bring the differentiate sigma and pi bonds. Like these questions are expected for 3 or even sometimes 6 marks. So, you can summarize everything what we have discussed here in the table, and it would be better if you write the answer in the form of table here. So, the here sigma bond